हेलो एवरीवन, माय नेम इज़ करण मशरू। वेलकम टू दिस वीडियो। और इस वीडियो में हम डिस्कस करने वाले हैं द डायनेमिक प्रोग्रामिंग अप्रोच टू सॉल्व द सबसेट सम प्रॉब्लम। सो फर्स्ट ऑफ ऑल लेट अस डिफाइन व्हाट इज सबसेट सम प्रॉब्लम। सो सबसेट सम प्रॉब्लम जो है, इसमें आपको इनपुट में दो चीज़ें दी गई होगी। एक एरे दिया होगा जिसमें कि n पॉजिटिव इंटीजर्स है, एंड इस एरे के अलावा एक टारगेट वैल्यू दी गई होगी। ठीक है, तो हमें बताना है कि क्या इस एरे का कोई भी सबसेट एग्जिस्ट करता है सच दैट द सबसेट सम ऑफ दैट सबसेट इज इक्वल टू टारगेट। ठीक है, फॉर एग्जाम्पल अगर एरे में n एलिमेंट्स है, ठीक है, तो टोटल नंबर ऑफ सबसेट्स कितने हो जाएंगे, 2 की पावर n। तो इन 2 की पावर n सबसेट्स में से क्या कोई भी ऐसा सबसेट एग्जिस्ट करता है सच दैट सबसेट सम इज इक्वल टू दिस गिवन टारगेट वैल्यू। इफ यस यू रिटर्न ट्रू, अदरवाइज फॉल्स। ओके, और बेसिकली यू प्रिंट सबसेट एग्जिस्ट, अदरवाइज यू से सबसेट सच सबसेट डज नॉट एग्जिस्ट। फॉर एग्जाम्पल अगर मेरे पास एक एरे है जिसमें कि एलिमेंट्स है 2, 10, 4, 20, then let's say 32, then let's say 18, and let's say I have 12। ओके, सो यहाँ पे 7 एलिमेंट्स है एंड टारगेट सम है, लेट्स से द टारगेट सम इज लेट्स टेक इट टू बी 52। ठीक है, सो डज देयर एग्जिस्ट एनी सबसेट हुज सबसेट सम इज इक्वल टू 52? यस, I can take the subset 2, 32 and 18. So 32 and 18 is 50, 50 plus 2 is 52. So we will say yes, subset exist. But अगर हमें बोला जाता target sum 53 है, then we will say no, subset does not exist. There is no subset of this array whose sum is equal to 53. ठीक है, so basically यहाँ पे हम क्या कर सकते हैं, basically so the brute force approach would be what? To brute force approach would be to generate all subset sum and compare it with the target sum, and if we get any subset sum whose sum is equal to target, will return true। ठीक है, अब टोटल कैसे सारे सबसेट्स जनरेट करने हैं हमने देखा है रिकर्शन एंड बैक ट्रैकिंग में, टेक नॉट टेक की अप्रोच से। तो टोटल 2 की पावर n सबसेट्स होंगे। ठीक है, now what else I can do is I can see whenever I take an element I can reduce that value from my target। for example मेरा target है 52। now let's say if I decide to take 12 in the subset, so the remaining target will be 40। I can also do in that approach। तो अगर मेरा remaining target 0 पहुंच जाता है, इसका मतलब मैंने जो भी सबसेट सिलेक्ट किया है उसका सम टारगेट सम के बराबर है। फॉर एग्जाम्पल मेरा टारगेट 52 है, ठीक है, देन वाइल जनरेटिंग द सबसेट्स आई डिसाइड टू टेक 18, सो माइनस 18, सो द रिमेनिंग वुड बी 34। then I decide to take 32, so minus 32, my target remaining would be 2। then I decide to take this 2, so remaining target would be 0। so whenever the remaining target sum becomes 0, it means I have selected the elements whose sum is equal to target, right? So what I will do is I will just write this array again here। so it is nothing but what, 2, 10, 4, 20, 32, 18 and 12, right? and now my target is 52। so what I will do is I will write a recursive function n comma target, which basically will return me true or false। so what does this function say? It says that whether it is possible to get a subset of the first n elements whose sum is equal to target। okay, so now I will decide for the nth element। so for my question I have 7 elements and target is 52। now I will decide for the 7th element whether I want to take it in the subset or not take it। so either I will take it in the subset or not take it। so in any case the number of remaining elements will be 6। once you decide on the 7th element, remaining elements would be 6, and if you decide to take this, the remaining sum would be 40, and if you decide not to take it, this will remain 52, right? Now the next thing is what you can do is, now this is whether you can get a subset of the first 6 elements whose sum is 40, whether you can get a subset of the first 6 element whose sum is 52। so now you will again do the recursion, right? so again you will say whether it is possible, now the remaining elements will be 5, and if you decide to take the 6th element, then 40 minus 18, the remaining sum would be 22, and if you decide not to take it, the remaining sum will remain 40 only। here if you decide to take that element 18, then the remaining sum would be 34, and if you decide not to take it, then the remaining sum will be 52 only। right? So basically here the subset generated is what? Here you decided to take 12, here you decided to take 18. So here the subset generated 12 now is 12 and 18. Here it is only 12 because you decided to take 12 and not take 18. Here you decided not to take 12 but decided to take 18, so the subset generated is 18. And here you decided to take nothing, so the subset is empty, right? So initial required sum was 52, here it is still 52, here it is 34, here it is 40, and here it is 22. But we do not need to maintain this subset generated, because here I only want whether it is possible to get a subset sum among any subset whose sum is equal to target. So I will only maintain this remaining target value. Okay, this is only for understanding that when you select these two elements, the subset you are considering right now is this. Okay, now, so in this way the whole recursion will go. Now here basically when will you backtrack? So backtracking is either you will get a dead end or you will get a valid solution or you will reach to a base case. Now what is a dead end in this case? See, if you take the elements in the subset whose sum is more than required, then that's a dead end. For example, you decided to take a 12 and 18, now remaining is 22. Now you also decide to take 32, so the remaining elements will be 4 and the remaining target sum would be minus 10. माइनस 10 का मतलब क्या है कि रिक्वायर्ड 52 था बट आपने टोटल सबसेट में एलिमेंट्स ले लिए जिनका सम 62 है. आर यू गेटिंग माई पॉइंट? एंड एरे में सिर्फ पॉजिटिव इंटीजर्स है, यहाँ पे हमें क्वेश्चन में दिया गया है, ठीक है. तो अगर सिर्फ पॉजिटिव इंटीजर्स है तो ऑल्दो यू कैन गो इन रिकर्शन फर्दर ईयर, क्योंकि नंबर ऑफ एलिमेंट्स आर स्टिल रिमेनिंग, 4 एलिमेंट्स आर स्टिल रिमेनिंग, बट यहाँ पे ऑलरेडी मोर देन रिक्वायर्ड आपने ले लिया है and the elements are only positive, so now you will not get any solution here, so this is a dead end. ठीक है. Then what is a valid solution? So when your target becomes 0, right? So let's say you decide not to take 12, right? Then you decide to take 18, so you are here. Then you decide to take 32, so the number of remaining elements will be 4 and the remaining sum would be 2. Now you decide not to take this, not to take this, not to take this. Okay, that can be one path. I mean, there will be the whole recursion, but I'm only drawing the solution which will make you reach till the required solution. Okay, and let's change this. Okay, so let's take 2 year and 4 year. That would be better understanding. So you decide not to take 20. So if you do not take 20, the number of remaining elements are 3 and the remaining sum is 2. Now you decide for the third element. Okay, just a second. Here you take 4 and here you take 2. Okay, okay, I think I changed it somewhere else. Okay, so now you decided to not take this, decided to take this, not take this. Okay, so don't take 12, take 18, then take 32, and now don't take 20. Now you decide to take 2. So if you decide to take 2, then the number of remaining elements will be 2 and the remaining sum would be 0. Now although there is further recursion left here, but because you have already reached your target 0, okay, although there are 2 more elements remaining, but since you have got target 0, it means you got a subset whose subset sum is equal to the required. So from here you can return true, from here you can return false. Okay, so that's this is the dead end, this is the valid solution case, or you will reach to the base case. Base case means the number of remaining elements becomes 0, okay, but there is still some sum left. Okay, so for example, you decide not to take this, not to take this, and so on. So ultimately what will happen is the number of remaining elements will become 0 along this path, but the remaining sum will be still 52. So in such cases, when number of element becomes 0, but there is still some target sum left, but now this is the base case, you cannot go further, right? Because there are no more elements. So in that case also you will backtrack. Backtracking means going back to the previous call, undoing the changes and going to look for other solutions. We saw in detail in backtracking class, right? So this is how the recursion will work. Okay. Now the thing is, if I write basically the recursion for one of the cases, for example, if I take an array, okay, and if I say 2, 3, 10, 5, okay, and let's say the target sum is t, total there are n elements. So you write function of n comma t, okay, which is it will return you true if there is a subset of the first n elements whose target sum is t. One more thing, So between these two, you will take a bitwise OR. Okay. So basically either you get, so let's say this returns false. Okay. Which means what? Not taking the seventh element on this path. When you decided to take the seventh element, there is no possibility of getting a subset sum 52. But here, when you decide not to take the seventh element, you return, you get true, let's say, suppose, which tells that there is some subset whose subset sum is equal to 52 along this path. Now, it doesn't matter whether you get true from here or here. If you get true in either one of them, it means you are getting a subset with subset sum 52 somewhere. So you will return true. If you get true from both the ends, that's well and good. You are getting a subset from both the ends. But if you get even from once, then you will return true. If you get false from both the directions, then you will return false. There is no subset. So here between every two calls, taking or not taking, you will do a bitwise OR. Okay. So now here, let's say for this example, there will be two cases. You take this element or don't take it. Okay. So the remaining elements will be n minus 1, and if you take the last element, the remaining sum would be t minus 5, and if you don't take the last element, the remaining sum would be t. Now let's say you decide not to take 10 in both the cases. Okay. So here it would be n minus 2 and t minus 5. Here it would be f of n minus 2 and t minus 5. T will remain t only. Okay. So I'm not drawing the complete recursion. I'm only going through a specific branch. Okay. Now here you decide not to take this and not to take this. Okay. So it will become f of n minus 3 comma t minus 5 and f of n minus 4 comma t minus 5. And here you decide to take this and this. So it will become f of n minus 3 comma t minus 3 and f of n minus 4 comma t minus 5. Now what does this tell? Whether it is possible to get a subset out of the first n minus 4 elements with subset sum t minus 5. This also tells the same thing. Although the branches are different, here the subset till now has 5 and the subset here has 2 comma 3, but the remaining elements and remaining target sum is same in both of them. So the recursion here and here would be absolutely same, and they both will return the same value, either true or false, right? So these are nothing but what? Overlapping subproblems. The same subproblems which are being called again and again in order to solve the main problem, right? And this problem is also using the optimal substructure property, right? Because we are using the solutions to the subproblems to build the solutions to the main problems. For example, here you will either take this element, okay, whose value is 3, or you will not take that element. So it will be f of n minus 3 comma t. Now you will use the solutions to this subproblem and then fill up the solution for this. So either this will return true or false, false or true, or any combination. Using that you will fill the solutions to this, right? So you are using the solutions to the subproblem to calculate the solution for bigger problem. So you also have the optimal substructure property. So here you can make use of dynamic programming, right? And here basically what we will do is we need to store the result either in memoization or tabulation. We need to store the results to the subproblem. So what kind of DP array we will take? So basically you can see in the recursion these two parameters are changing based on which we are making our recursion logic. Okay. So our DP, so if you write down the actual recursion here, then actually that will have some more parameters. Okay. But the main recursion logic is based on these two, whether we have found a solution or whether there is a dead end or base case or something like that, right? So I will take a DP table of size n comma sum, okay, which in which DP of ij will denote what? Okay, so this will be n plus 1, okay, because I want till nth index, okay, where DP of ij will tell us what? So just small change. Here also I will take sum plus 1, okay. So this will be the DP table which I will take, where DP of ij will denote what? Whether it is possible to get a subset of the first I elements whose subset sum is j. So this will be either true or false, okay. Or you can take this integer array where 1 will denote true, 0 will denote false, and minus 1 will denote that is not yet calculated. Okay, so this is what the DP of ij will denote, and our answer will lie at this index, DP of n sum. whether it is possible to get a subset of the first n elements with the target sum. Okay, so now in the next video we will see its top down as well as its bottom up approach, but we saw how it is a dynamic programming problem. I hope you understood everything in this video. Thank you.